some 150 million kilometers away, hydrogen atoms are fusing together under intense pressure, releasing tremendous amount of energy. This energy is the reason for life on our planet. ITER, the largest experimental project, with the collaborative effort of several countries, is taking shape at Cadarache in France to demonstrate the feasibility of continuous fusion and to extract the heat generated during the process. For the first time, nuclear fusion will create a clean and a seemingly infinite source of energy on a commercial scale. But to produce and sustain plasma, 10 times hotter than the core of the Sun, the plasma needs to be suspended in vacuum without touching the vessel walls. This is achieved by using strong superconducting magnets. These magnets and the cryopumps will operate at only a few degrees above absolute zero. These temperatures are obtained by circulating a steady flux of cryogenic fluid, helium, through a complex network of high-technology, double-walled piping, the ITER Cryolines. The contract to design, manufacture, supply and install Group Y helium, Cryolines and Warmlines was awarded to INOXCVA of India. The contract was to deliver about 4 kilometers of cryolines and 6 kilometers of warmlines. The cryolines would carry supercritical helium at under 4 Kelvin temperatures, from the cryoplant to the different valve boxes and cold boxes in the tokamak building and back.
We were truly in uncharted territory. Such kind of an experimental research reactor was being done for the first time in the world, and therefore the standards which were required in terms of quality and in terms of all the specifications were a completely new thing. We had the quality and the capability within our organization. However, we had to set everything in a manner in which we can make sure that it meets the international standards as well as it is verifiable by everyone.
A separate manufacturing area was created at our Kannur works to manufacture the ITER Cryolines. We also created a clean space of 100,000 class cleanliness to manufacture these cryolines and do the wrapping of multi-layer super insulation in this area.
One of the prerequisites of the contract was to make a 27-meter-long prototype cryoline with multi-process piping having a T-branch and 80K shield. This prototype was a small section of the actual cryoline, which had the most complex bends. Only if the prototype passed all the stringent test parameters, the work on actual cryoline manufacturing could start. The prototype testing passed all critical parameters, including thermal performance. The manufacturing of the cryolines began in 2017. Due to the complex nature of the cryolines, which had several angles and bends, joints had to be welded with the highest precision and skill. The quality of the cryolines had to create a new benchmark. The internal surface of the pipes were checked by boroscopy, and the weld joints were X-rayed and cold tested with helium leak detection test. INOXCVA has manufactured 745 spools of 14 different types of cryolines and 1,270 spools of 22 different types of warm lines, along with the support structures. Once each stage of the cryoline was ready, they were transported to ITER, France. Assembly at the site was also a crucial activity, as the team had to work in confined spaces. The lines were welded and quality checks were performed at every stage.
In terms of performance of INOX, I will say that they delivered on time, on quality, and it has been done in the perfect way, I will say, in the best way, without any incident, without any accident, without any lost time. In the perspective of the ITER project, it has worked in a way at par with any other international level that I can imagine.
Today, I'm so happy and I'm very proud to have motivated the company to work on this subject, because we have realized the successful completion. But this is also the demonstration how this company can be largely involved in many other subjects which are critical from technological and scientific point of view. For me, this is just the starting point for big, additional, new challenging adventures. Thank you so much for that.
At INOXCVA, we take immense pride in contributing to a project as visionary and globally significant as ITER. Our role in designing, manufacturing, and executing the Cryolines, critical to the world's largest fusion energy experiment, reflects our deep-rooted commitment to precision engineering, innovation, and global collaboration. This project is not just about technology, it's about humanity's shared pursuit of clean, limitless energy. I'm proud of our team for upholding the highest standards of quality and safety and for placing India on the map of advanced cryogenic solutions. For us, this is more than a milestone, it's history in the making.
ITER plans to demonstrate power generation through fusion sometime in 2035. Its success will mark an iconic moment in our planet's history. INOXCVA and India will be proud partners to witness the first step towards creating fusion energy that can be commercially produced for a cleaner and greener future.